Okay, hello everyone, and this is the additional video for your exercise to prepare your midterm, and hopefully I have time to take out several questions for you guys. Okay. So let's start with this question. Okay, so you can stop the video and check your work, and then later compare with my results. Okay, let's start. Okay, let's read the questions first. Okay, let g, a function g, is equal of a function of x squared, where f is twice differentiable for all x. And this is the idea that important. Okay, so the f prime should be positive for all x not equal to 0, and the function is concave downward on this interval and concave upward on this interval. Okay, at what numbers g have an extreme value? Okay, so first we need to define the critical point for g. Okay, that is, we can find through, let me write the g. Okay, let's try to derive this function g. So g prime, okay, and this will be f prime x squared, and this will be 2x, so I will write 2x f prime x squared. Okay, so by chain rule. And we know that the f prime x is positive for all x not equal to 0. Okay, okay, so because of this, we need to have g prime of x equals 0 to take our critical point, right? Okay, we can summarize that the function, or not the function, g prime change sign at x equals 0. Because f prime x squared is positive. And if we look at the line number, if we want to check, okay, so this is 0, and we have 2x f prime x squared so when 0 is when the x is less than 0, it will be a negative, and this will be a positive, so it will be going down, going up. So x equals 0 is minimum value, or minimum, or is absolute and local minimum. You can, or local minimum. Okay, and then this is a question for number A. For B, we need to discuss the concavity, so let's check that out. Okay, let's write down the first derivative is 2x f prime x squared. Okay, the second derivative, it will be, we need to derive this and make it so we can have a product rule. So let's make this 2 outside like that, f prime x squared plus, okay, x multiply with f double prime x squared, and then 2x we can write this as f prime x squared plus 2x squared f double prime x squared. Okay, I think it's correct. And then we can multiply with 2. So this will be 2f prime x squared 4x squared f double prime x squared. Okay. So x squared will be positive for all x not equal 0, right? And this will be positive since the question is having the concave upward from 0 to infinite, right? Since the f is concave upwards for x positive, right? And also the f prime x squared is positive also for all x not equal 0. Okay, so because all these factors is positive, so let me write again. Let me write here. So g double prime is okay. Let me write again here. So this will be positive, okay? This will be positive, okay? So the only way to get the concavity changes is from the x, right? Okay, so when we take this to equal 0, the only way to do that is by looking at the x, right? This one here. X should be 0. But because f prime x squared is positive, okay? So the function g is always concave upwards because it's always positive. Okay. Okay, so the idea here is because this is positive, the only way we can make this second derivative 0 is by taking x equals 0. Okay. But then if x equals 0 here, okay, it's still just taking this part 0. So the other part's still positive. So because the f prime is always positive, okay, and the function will always be concave upwards, okay, on all real number. Okay, that's the number b. Okay. Okay, I hope you get my explanation here. Okay. Okay, now let's move on to another example. Okay, now it seems really complex limit, okay, but let us see if I can solve it for you. Okay, um, notice that we have tangent here, right? Okay, tangent 1 over x cubed. Okay, remember that if we have, okay, limit as x going to 0 of sine x over x, it's equal 1. And if we have limit as x approaching infinity of same limit here, it's also 1, because 0 and infinity is, we can exchange each other within this relation, because 1 over 0 in limit is infinity, or 1 over infinity is 0, so we can have the same conclusions. Okay, so remember of this. And of course, if we have tangent, this is also similar or equivalent with the sine. Okay, so we can have sine x over cos x over x, right? So because cosine is going to be 1, so it will be similar with the sine. Okay, okay, now to tackle this problem, okay, first let me rewrite this, and we need to take the one here to be having 1 over x cubed. Okay, if we want to do that, then we need to multiply this with x cubed. Okay, and I think because it has x here, we can take that x going down here and become 1 over x. So our solutions, or our calculation here, becomes, we have square root here, x power of 6 okay, and this part will be just x squared. Okay, okay, now if we take this limit here, let me write limit here, this will be equal 1. Okay, now we are just focusing on this part. Okay, now we have the negative here, so we need to take rationalizations. Take the positive part there, and taking it, okay, let me write here, so it's okay, maybe let me take it x. Okay, so it will be cancelled, so we have negative 3x with power of 5 plus 1. Okay, okay, now this will be, okay, we can take this approach and divide by x to the 5, I think, if we try that. So we can have, let me write here, negative 3 plus 1 over x 5 . This will be 1 over x cubed . or maybe let me take it inside all this number. Sorry. So x squared going inside, it becomes x with power of 4, so it's x10, right? And then minus 3x9 plus x4, right? Okay, slowly, we take it slowly, very slowly. Okay. So this will be 1. This will be that. This will be and this will be 1 over x squared, right? Oh, sorry. I think I make a mistake. This should be x5. Okay. Sorry. It should be x5. So this should be 1. Okay. So this will be should be, because it should be multiplied with this x squared. Okay. So this should be x squared. The original one is x6 negative plus x cubed. So that's why it should be x5. Okay, now we're going to see that 0 0, so it's 1, so 1 plus 1 is 2, so this will be negative 3 over 2. Okay, I hope you get my method here. Okay, if you check the limit itself, if you check, you need to have whether you can use L'Hopital or not, right? You need to check whether it is indeterminate form or not. Okay, and then maybe you need to rewrite in some way that when you have this indeterminate forms, you can do some L'Hopital rules. Okay, next part. Okay, this one. Okay, it's again a little bit complicated functions, but let's try and then let's check whether we can solve it or not. Seems that it's complicated, right? If you try find f prime f with this, okay, this will be crazy, right? So let's try not doing that. Okay, we need to think another way that is more more possible. Okay, let's write here. Okay, let's write this definition first, so that this definition is, I believe, sometimes it's really become a powerful tools when you're dealing with some complicated functions. Okay, let's try to take the f of x in terms of okay, so that I can have more clear view. Okay, let me separate this. And maybe let me separate also the, if we plug in 0, what will happen? It will be, this will be 3 secant cube x is secant 0 is 1. And the tangent of 0 is 0. So it should be 0, right? It should be 0. So you don't need to think much about this one. So this should be 0. So this will be okay. Let me write here. Maybe make it smaller. Make it smaller. Okay, maybe here. Okay. Okay, limit. Okay, we are doing the limit now. F of x divided by x. Okay. Still, we get the 3 secant cube x. Okay, and I will write the x inside here, the tangent here. So this will be so I will write this, making it divided by x. Okay. And the left part here, we have 1 over 3. Okay, if we check the 0, so we are going to just evaluate the right one. So again, we have a tangent. Like I mentioned before, if you have a tangent, you can make sure that it's equal 1. Okay, so how to make it? Okay, first we need to take this to 2, and we need to also multiply the top one. So 2 tangent to x, okay, and then this is cos inverse x plus ln 1 plus x. Okay, so this will be 1 over 3. This will be 1. Okay, this will be 1. This will be 1. Okay, and then multiply by 2, so it's 2. And then cos inverse x is, when you plug in 0, should be pi over 2, right? And plus, this is ln 1 plus x over x. So maybe I will write this as limit. Okay, and let me write at the bottom here. So this will be pi plus, let me write here it's at the right side here, small notes for the ln. This is, you check, it's 0 over 0, so you can do L'Hopital rule. So L'Hopital becomes 1 over 1 plus x over 1, so it should be 1, right? Okay, so we can plus 1 here, so the answer will be pi plus 1 over 3. Okay, so if you are dealing with something strange like this one, before you try to do anything that leads you to confusions, like maybe you try directly using a quotient rule, or maybe thinking to maybe using some identity for trigonometry, maybe you try to take this like this one here. Breakdown becomes two structures. Okay, and looking at the first one, looking at the second one, what you can do to simplify, or maybe something that is maybe helping you along the way. Okay, that's the answer. Okay, I hope you understand my method here. Okay, next one is this. Okay, it's still about the limit, and I think this this is needed because of inside this kind of question we can have a lot of summary, right? We can have a discussion about continuity, we can have discussion about derivative. Okay, and to start with, okay, you can check and try for yourself. Okay, so we need to check the limit as x approaching 0 of the function. Okay, because we know that so for f0 is 0 from here. Okay, so we need to check continuity. So continuity means that this should be equal 0, should be, okay, to be continuous functions, right? Okay, so check continuity for number A. Okay, because it's asking is f of x continuous at x equals 0, right? So first, let's start with the cosine. It start off with this informations, okay, from the cosine value, that is the minimum is -1, the maximum is 1, and then we can also apply or multiply both sides. We multiply with this so that it will resulting the original function that we are going to evaluate. And we know that if we try to take the limit, this is the same results, that is 0. So by the squeeze theorem, limit this also 0. Okay, and because at x equals 0 the function is also 0, then f of x is continuous at x equals 0. Okay, so that's the first question A. Okay, the number B, compute f prime x for x not 0 and f prime 0. So B. Okay, let's try from our definition here. Okay, so we can write the derivative. Okay, and we can have this limit and this also getting us a very similar form with the original equations, and we can decide that this is also equal 0 by a squeeze theorem. Okay, you can write yourself the theorem, okay, for taking this. And I think because it has the same similar form with the original one, it's still 0, right? Okay, we need to also consider if the x is not 0. So we need to take the limit, okay, not the limit, sorry. So we need to take the functions. Let's just write the functions, okay, and take the first derivative. This will be 4/3 x 1/3 cos 1/x plus x and this will be minus sign. Okay, let me write minus sign, and then minus 1/x squared. So it will be 4/3 so x squared, it will be -2. -2 is -6/2, so it will be -2/3, right? Okay, and then sine 1/x. Okay. So this is our f prime x. Okay. Okay, now to check the limit whether it is continuous at x equals 0, the limit, the f prime, check the limit x from 0 positive of f prime, and check also x negative from f prime. Okay. Okay, you will notice that because of we have now cos and sine. Okay. If you check 0 from the right, you will have a different results. Okay. You can check with x is equal 1/t. Okay, let's say with 1/t, and you can evaluate cos t and sine t. Okay, if you draw this is cos, this is sine. When you have the cosine, when you are approaching to 0 from left and right, notice that for cosine it's not having a big problem here, but if you plus with something sine, you're going here and you're going here, and of course oh, sorry, not zero, because x is 0, so t is infinite. So because of the difference between cos and sine, okay, for the angle of view, so if I draw this, it's always having the pi/2 difference in both of cos and sine, right? So at one time, when cosine is going up, sine will be a little bit down, or reversely, when cosine is down, sine is going upward. So in the sines, okay, I hope you understand my idea here. So sometimes when it is going to have like the results, for example, if this result is infinite, this will be negative infinite. Okay, if this is negative infinite, this will be, so it will be not going to be the same. So we can conclude that this is not the same. So f prime x is not continuous. Okay, I hope you get the idea there. Okay, next question. Suppose that surface blah 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 okay, circular cylindrical solid is 1. Okay, first is surface area of cylinder, right? Of course, this will be the picture. So you will have 2 circle, right, for the area, plus the one at the middle. If this is h, then this will be 2 pi r h. 2 pi r is because this is, if we break down, so this 2 circle here, and this is the rectangle. The rectangle is from, this is h, this is 2 pi r, the circumference of the circle, right? Okay, so that will be our surface area, and it will be equal 1, and will be our constraint. Okay, and we can take this and make it into h, okay, because I think we will be able to using just variable r here, okay, instead just r and then taking h, because r has the square. I think it will be more complicated if we do that. And maximal volume, so volume is our optimization, so volume is pi r squared h, right? So this will be optimization. Okay, we take the h from our constraint. Okay, take some time to solve this. Okay, so pi r, okay, so r and then divide by 2, so it will be v is r minus 2 pi r to pi r cube, right? Okay, is this correct? I think it's correct, right? Okay, so we take the first derivative. So 1 6 pi r squared, right? Okay, take this equals 0. We take it for finding the critical point, and we get so r is 1 over 6 pi squared. And r is 1 over square root of 6 pi. Or yeah, I think this one. And if we check the phi double prime, this will result in negative 12 pi r divided by 2, negative 6 pi r. So it says phi prime is less than 0. So we are having the concave downwards. So it's true that it's a maximum value for this point here. Okay. So the local maximum is, if we plug in this point, pi r squared, and h is, okay, we need to write all, okay, 1 minus 2 pi, okay. Two pi, oh, r squared, sorry, this is having same r squared. Okay, if this happened in the exam, okay, and you feel that this will be exhausted, so just stop here, okay, this it's complete. Okay, so r will be here. Oh, what is the question? Oh, just height and radius. Okay, so height and radius, so just radius is this, and height is just this. Okay, if you want to compute, this will be, I think, this, right? Okay, but I hope you get the point here. Okay. Yeah, I think that will be the end of my additional video today. I hope you get more practice, okay? And I will upload the last year, not last year, the 2018 answers, okay, on Google Classroom. Please check out later.